third session is gonna be still later, right? 5 p.m. This is the an additional session. Think about this additional session because you had your mock papers. You were given mock papers. Yeah, yeah. Still later at 5. I'll still see you later at 5. So the mock session is different, right? Because you were given a copy. You were given a copy, but odds are you may not be able to solve it. So let's try to view through, right? Let's try to view through your mock exam, right? So let's view through. All right. Okay, so first off, given that the first 2015 positive actually if it's delayed because it's way back from the mock papers gives you were maybe from like 2015 possible like it's been a while. It's been a while. So not entirely accurate, but since it was given to you, we'll still gonna view that one. Still gonna do that one. All right. Given that the first 2015 positive numbers, there are 305 primes. All right. So for the first 2015 positive numbers, how many have more than or equal to 4 positive factors? So we're talking about 4 factors, 5 factors, 6 factors, 7 factors, 8 factors, 9 factors, 10 factors, 11, and more. All right. And it's kind of a lot. It's kind of a lot because the issue here is gonna be we can't count 4 and up. It's like too much. So what we're gonna do is we want 4 and up, right? So we're gonna remove numbers that have 3 factors and below. So 3 factors, 2 factors, and 1 factor. What number has 1 factor? There's one, like literally one. One is divisible by one. End of story. 2 factors. What kind of number has 2 factors? Prime numbers, because by definition, primes are divisible by one and the number itself. So they actually gave us the number of primes. So all right, 305. All right. So let's look at how many, numbers with 3 factors are there. So 3 factors, that should be the square of a prime. So give me an example, sir. 2 squared, right? 1, 2, and 2 squared. That's its factor. Like 9, diba? 9 is 3 squared. So 1, 3, and 9. 25, 1, 5, and 25. Squares have 3 factors. Perfect squares have 3 factors. So what we need is we need to know how many perfect squares there are from 1 to 2015. If you look at that one, what are the numbers that are close to 2015? Now note that 43 squared is 1849. Maybe 33 or 30 43 or 47, right? 47 squared. Squares of prime. My God. Squares of prime 2209. Right? So the closest square of a prime is 1849, which is 43. So we have 42 numbers here. Right? All right, 43. Right? So from 1 to 43, how many primes are there? 1, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, and 43. There's 14 prime, no? There's 14 prime in between 1 and 43. Okay. So we have our 2015 minus the numbers that have 1 factor, 1 only. Minus the numbers that have 2 factors, 305, and minus the numbers that have 3 factors. I think so. I think so. I actually recorded it. Actually recorded it. So not really sure. I will just if you need a copy, if it probably will be recorded and sent to you. If you don't receive one, just ask monthly for that one. It'll probably give you a copy. But I have recorded this one for future reference. If you need it, you can ask for a copy. Okay. So minus 14. So our final answer should be subtraction 1695. Okay. Next up. Peter, all right. We did this before. We're gonna draw an arbitrary, not really a straight one, but I do try. arbitrary Cartesian plane. Okay, so we're gonna go which color? West. Okay, this is my north, south, east, and west. Now you can have your own arbitrary set of points. You can. Some people like to put south on the top, or you can put east on the left and west on the right. That's your option. Okay. You go west for 33. All right, west for 33. Okay, 33. And then you go north for 24. North for 24. And then you go east for 17. And then you go south with 12. All right, so what's the final distance? What are we looking for? We're looking for this one here, right? We're looking for this one here, all right? So what do we know? We know that we have this one. We need to get this one and this one here so that we can form a Pythagorean theorem there. So we could get this side. This side is just 12 minus 24. This is 12 because this side is 12 on the top. This side on the bottom should be 12. And the side here that should be 33 minus 7, right? Which is 16. Okay. So we do have this one and that one. We're just gonna deal with Pythagorean theorem for that one. So this side C. So C is the square root of 12 squared plus 16 squared, which is just equal to 20. That should be our final distance. Ta-da! Next up. Very tricky one. Very tricky one. Most of you guys would do trial and error, but let's try to deal with this one without using that trial and error, right? Okay. So we're gonna calculate. It says here that it's a 6-digit number. Doesn't say if there are any digits repeated or not. We don't know for sure at the moment. It just says if you multiply it by 4, the numbers get arranged. The numbers get rearranged, sorry. So what's that number? All right. What are we gonna do here? I notice here, at first glance, I notice that you still have A, B, C, D, and you have the E, F, right? And it becomes E, F, A, B, C, D. What happened? They just swapped the part A, B, C, D with part E, F when you multiply it by 4, right? They swapped those two parts. All right. So if I'm just gonna convert this into place value form. Now notice that A, B, C, D is in the hundreds, right? So I'm gonna write this. If I'm gonna write my equation, 100 A, B, C, D. Why is it? Or you can, I know we could for the sake of like make it ease of solving, we could go let X be A, B, C, D, and let Y be equal to E, F. So just for the sake of like not writing too much in our solution, all right? So A, B, C, D or X, that's in the hundreds place because there's two places before it, X, plus EF, which is Y. And we're going to multiply that by 4. Okay. On the other side, the EF or Y, it has how many places before it? 1, 2, 3, 4. So it's 1000 Y plus X. Okay. So we're able to handle that one. Now, what do we have here? We have an equation. We can just simplify this one. So we're going to transpose that there. 400x plus 4y is equals to 1000 y plus x. And I'm just going to move the x's on one side and the y's on one side, right? So 1, 2, 3, 4. 1, 2, 3 hundreds. Oh, I forgot the 0. In the 10,000 pala. My bad. It's like 5 zeros. 2 zeros. All right, 5,000. 4 zeros. Forgot, have 4 zeros there. All right. Yeah, 10,000. Yeah, my bad. My bad. Thanks for that one. Thanks for that one. All right. Transpose, subtract, simplifying. We should get something like 399x. I moved 1x on the other side, and I'd be like 9996y. Right? 399x and what? But is this simplifiable? Yeah, that's pretty much simplifiable. I could divide both sides by 7. They're both divisible by 7. So 399 divided by 7, that's 57x. That would be equal to, divide this other side by 7, 1428y. So what should I do here? This one. Why is it 100x? Well, and 10,000y. Very interesting, no? The thing is, I did that one. No, the reason I did that one is because of the placed value. Now the ABCD is like it has like two places before it, right? So I'm gonna put two here. You can think of it this way. You can think of it this way, right? So when you say 791, that's 7 times 100 plus 9 times 10 plus 1, right? It's the same logic in that. So we are considering its place value. Like the ABCDF, it's in the hundredths place. It starts in the hundredths place. And likewise, the EF here on the other side starts in the 10,000th place. So we're gonna need to multiply 10,000. What if we don't multiply like a multiple of 10 there? It should be that it's in the ones place, but putting these numbers signify that it has the value, a few digits before it. No, it has a certain magnitude to it. Okay. So we're just gonna flip it over and our answer is gonna be x is 1428 and y is 57. And replace it back. X is ABCD and y is EF. All right. So we're looking for F AB EF ABCD. So EF ABCD is gonna be 5, 7, and then 1, 4, 2, 8. This should be our final answer. Ho, ho, ho. Next up. Okay. There are 30 problems in a math contest. The scores of each problem are allocated. Wait, there is actually multiple. Hmm. 761904. Oh, interesting. So interesting. 761904. Hmm. Can we still simplify it a bit? Huh? Yeah, actually, you can go lower. Actually, that's true. That's true. You can go lower. You can actually go with 19x is equal to 1428 divided by 3, 476. No, y. You can actually go lower with that one. That the issue here is, 50 says 76. You can go with 76. So what you did here is you multiplied everything by 4. Interesting, right? You multiplied here everything by 4. Yeah. I actually don't, I'm not familiar with this, with how HKIMO will rate things. I'm saying it's true, it's true, it's right. You can actually go with that one. It does follow the similar ratio. You make sure the place values match with AB. Yeah, that's what you do. You match the place values. For this one, this is actually pretty valid also. I didn't think of that one. You can divide it. You can do 4. But is it valid? If ever you're gonna do that one, HQ was probably giving it a check mark because it still satisfies, right? It still satisfies. You just multiply things by 4/3, right? Multiply things by 4/3. That's fine. You still have the ratio. So if ever it comes, yeah, it's gonna still be a valid answer. But as far as it, let me check the key. The key says, hmm, it's this one. But yeah, if I was gonna deal with that one, that's gonna be a valid answer as well, right? Wait, there are 3 possible. 3? Hmm. I think there's 3. 2. I think there are 2. Bah? Times 5? Yeah, we can do times 5 also, no? So divide by 3 times 5. Yeah, pwede. So divided by 3 times 5. So multiply by 5/3. You could also do that. Nice one. Nice job in noticing that one. Nice job noticing that one. Anyways, next up. 30 problems in the math contest. The scores are allocated in the following ways: 5 marks for a correct, 0 marks for a blank, or a wrong. All right. So what is my minimum score? My minimum score is gonna be 0, and my maximum score if I get a perfect score, it's gonna be 150. Why is it 150? 30 questions, 5 points each, that's 150. Now, what are the possible scores here? Um, if you get it wrong, nothing changes. You write it blank, nothing changes. It's not a right minus wrong thing, or not a right minus blank thing. So, what are the possible scores? 0, 5, 10, 15. Those are our possible scores. Those are possible scores, right? Because it's 5 points a question. It's 5 points a question. So, these are my score increments. So how many scores are there in total? 31. Sure, why 31? You can get 1.1 correct to 30 correct, and you can get nothing correct. So that's 31 possible scores, right? 31 scores. Now, what we're gonna do, we need 31. There are 31 options, but we need to ensure that 5 candidates will have the same score. How do we do that? Pigeonhole. Okay? So the number of possibility times how many we need minus 1 plus 1. That's gonna be 31 times 5 minus 1 plus 1. That's gonna be 31 times 4 plus 1. That should give us uno vencienko, 125. Okay. Next up. Wait a bit. Did I repeat that? Oh, I repeated that one. My bad. Okay, the light is on. Amy presses the like button. This is a large number. I gotta say, this is a large number. Hypothetically, she will. That's too much. No, I don't know how you'd write that like that. Now, light is on or off. That's binary. What do we mean? It's binary. It means you have like two options. We are gonna say on or off. Now, when is it on or when is it off? Now, at the moment, it's on. So if we you click it once, it's off. You click it twice, it goes back to where it was. So what can we say? If the number of clicks, think of it this way, if the number of clicks is odd, it's gonna be off, right? Think about it this way. The light is on, click it 3 times or 5 times or 7 times. It's gonna be off. But if it's gonna be even, click it 2 times, click it 4 times, click it 6 times, it's still gonna be on. Right? So the question here, we don't really need to evaluate this one exactly. We just need to know, is this odd or is this even? Okay. There should be a formula for this one. The formula for this one should be n plus 1, 2n plus 1 over 6. So I'm just going to plug in that one. That's going to be 33. N plus 1 is 34, right? And 2n plus 1 is going to be 33 times 2 plus 1, 67 over 6. Now, question here is this odd or is this even? You don't have to evaluate everything. No, we don't have to get the exact number. We just need to know if this is odd or this is even. Okay, is this odd? Is this even? So we'll solve this one, no? We'll solve this one. So we can cancel out the 3 here and make this 11. And cancel out the 2 to make this 17. So 11 times 17 times 67, I'm sure that's an odd because you're multiplying 3 numbers at odd. Okay, so that's one way to do it. That's the other one. Now, 1 squared is odd, right? And 2 squared is even. 3 squared is odd. 4 squared is even. And so on. The pattern goes as such. So if you're gonna end up with 1 squared, no, up here it's gonna be odd. 2 plus 2 squared plus an even, it's still gonna be odd. Plus 3 squared, it's gonna be even. Plus 4 squared, even. Then followed by odd. So you have a pattern like this: odd, odd, even, even, odd, odd, even, and such. So you can get that power. If it ends at 33, what's it gonna be? It's gonna be odd. You can do it like that. Okay, you can do it like that. So you have like two options there. Two options. Okay, so you can solve it like this or do odd, even patterns on the number if you're not familiar with the formula or do not want to deal with like the number part, you can deal with that. You can do it like that, right? Next up. Okay. 2028. All right, that's how many years? 10 years, right? 10 years. 1, 19, 20 to 22, 23, 24, 5, 6, 7, 28, 28. So 10 years. 10 years. All right. So it's, how many days is that? 10 times 365. But I'm gonna add something. I'm gonna add. What am I gonna add? I'm gonna add 3. No? Plus 3. Why am I adding 3, sir? Because if you notice, we have leap years. Leap years have a +1 on the day. So we encounter 3 leap years actually. 2020, 2024, and 2028 have leap years. So we're gonna add those 3 because of the leap years. And we're gonna do mod 7. All right. So 10 mod 7, that's 3. 365 mod 7, 1. Right? 364 is like, yeah, 1. And then plus 3. Mod 7. All right. So how much is that? That's going to be 6 mod 7. 6 mod 7. So what does that mean? 6 days from Saturday. All right. It's 6 mod 7. So it's 6 days from Saturday. What is 6 days from Saturday? Friday. 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 Okay. It'll be Friday. Next up. If A and B, ooh, I think we dealt with a similar one in our VTABs, no? So, um, sum of roots A plus B is negative B over A, right? Negative B over A, or if we have like AX squared plus BX plus C. Negative B over A is gonna be negative 7 over 2. So A plus B is 7/2. How about AB? AB is C over A, or 9/2. Right. So we have this one. We have our value 7/2 for A plus B, and AB is 9/2. We just need to get this one. What is this one? This one is AB times A plus B, right? Alpha beta, sorry. If I can factor it out, right? Alpha beta times alpha plus beta. So what does that mean? The product times the sum. That's it. So when I do this one, it's product 9/2 times the sum, which is 7/2. That should give me 9 times 7 is 63 over 4. All right. 9 over, ay, sorry, 1. My bad. 1. 1. Actually, look, I actually saw the squared and it's like, 2. My bad. All right. My bad. 63. Thanks for that one correction. Actually, when I'm looking at it, like, I'm looking at it at a very fast pace sometimes. So when I saw the 2 there at the square, I think it was, oh, the coefficient of 2. But yeah, thanks for that one. Thanks for that one. 63. Thanks for that one, Mr. John. My bad. Okay. Final answer should be 63. Next up. Woo-wee! That's a pretty tricky one. You have both your X's and your Y's. So how are we gonna deal with this one? No? What we're gonna do is we're gonna transpose all the variables on like one side. I'm gonna transpose all the values on one side. Like x squared. I'm gonna transfer the constants on the right. X squared plus 6x, and you're gonna have a minus y squared minus 4y. That's gonna be equal to 5. I know negative 5, my bad. What I'm gonna do now is I'm gonna try to form perfect squares with these guys on each side. So to form a perfect square with x squared plus 6x, that's gonna be plus 9, right? So I'm gonna add plus 9 on the other side. And the other side is gonna be minus 4. Minus 4. Minus 4. Okay. So what happens now? It's gonna look like the other side is gonna be 0, right? No, the other side is gonna be 0. So what's it gonna be? No, what's it gonna be? So it's gonna, if we can transpose that thing on the other side. Actually, there's an error on this. I know. I'll explain to you later, but I wasn't really consider it an error, but you can look at it as an error if you guys want. Like squared 3 minus y squared y minus 2, right? Equals 0. So the thing is, it's a minus sign. It should have been a plus sign if they wanted to design it properly. But because it's a minus sign, that would mean x, y can be, there's an infinite number of solutions. But as far as HKIMO is concerned, they actually want to do it like this, right? But originally, you can have literally an infinite number of solutions for this one. Yeah, sure. Well, you can drop it down while I'm just continuing this one. So x is -3 and y is 2, right? If you're dealing with this one, 0 is equal to 0. So when you have that one, xy should be -6. Wait a bit. Oh, -6. My bad. It should be -6 also. My bad. -6, -2. Negative, negative. And okay, positive, positive. Let's be positive. The meeting glitch? What kind of glitch? I'm not really sure. I can't really see any glitches on my part. If you could give the context as to that glitch, then that would be great. You know, that'd be great. Let's deal with this one. Okay. Okay. Now, what this is gonna look like when you simplify this is it's gonna look like uh something like an hypothetically it's gonna look like maybe a square root plus a square root, like square root of a plus square root of b is equals to the square root here. Hypothetically, it's gonna look like that. Okay. So what are we gonna do? We're gonna square both sides because we want this a and b because it has to look like that form if we simplify it. We square it, it becomes a plus b plus sorry, plus if we square this left side, square root 2 square root of ab. Yeah. 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 Very, that's a good, interesting. Oh, wait a bit. 12? Nah, you can need to recheck. That's 2a. All right. There's a, we're gonna edit that a bit, Mr. Levin. We're gonna edit that a bit. Is equal to 39 plus 12 square root of 3. All right. So we're gonna equate the ones with on whole numbers and the ones with radicals. So we're gonna say a plus b is equal to 39 because whole numbers with whole numbers, numbers with radicals with numbers with radicals 2 square root of ab is equal to 12 square root of 3. So I'm gonna simplify the right side. The left side is okay. No, a plus b is equal to 39. So I'm gonna simplify the right side, and it's gonna be square root of ab is gonna be 6 square root of 3. So I'm gonna square everything, right? AB is what's 6 square root of 3? That's 36,108. Okay. So we're gonna look for numbers. Two numbers that have a sum of 39 and have a product of 108. We have A is 36 and B is 3. Right? If you look for numbers that satisfy that one. Sir, can I swap it? A is 3, B is 36. Knock yourself out. Okay. So it's gonna look like the final answer. This one should be square root of 36 plus square root of 3, or we can just say 6 plus square root of 3 as our final answer. Okay. That's that for that one. Yes. If the date we're going to find it, yeah, a theoretical question. Sir, what if like per se, I chose Jan 11, right? January 11. That follows through what you're saying, right? January 11. Sir, if it's January 11, would it be the same solution? No, we should only put here +2. Why? Because we're not gonna consider 2028 as a leap year because it has to pass February. All right? For it to be counted as a leap year on that year, it has to pass February. So May passed February, so it's fine. But if January didn't pass February, so for year 2028, I'm not gonna put my +1 because it didn't pass there. No? for it to be a leap year because the leap year is placed on Feb 29. No, so if you don't have if you didn't pass Feb 29, don't consider that one as a leap year. I know it's still a leap year, but don't put the +1. Don't put the +1. All right. Okay. All real numbers. Okay, number 10. No? All real numbers, we're gonna find the integral value of k. Okay. So how are we gonna deal with this one? When we talk about the possible values here, we're talking about the possible values here. So it's less than, right? This is less than 0. So we're gonna go with discriminant, the discriminant. Right? The discriminant. And it's not equal to 0. It's actually greater than 0. Okay? Actually greater than 0. So what do we do? It's not an equal to. You're used to having discriminants with an equal to sign, but it doesn't have really an equal to sign. It's greater than. So we're gonna replace that with a less than. Just flip it over the opposite. Okay, because it's a less than. But if it's an equal to, we would still say equal to here. The thing is, it's not equal to though. Number 9 is number 9. We're gonna say yeah. In general, it does. Okay. So we're gonna replace it. Ax squared plus bx plus c, right? So b squared is gonna be k squared minus 4 times 4 times 2 to 5. Less than 0. So this is k squared minus, just gonna multiply this one. 450. When you multiply by 2, so 900 times 4, 36. So k squared is less than 36. Okay. So I'm gonna that one. We're gonna root that one. We're gonna root that one. So if we're gonna take a square root of both sides, k should be in between 60 and negative 60. Sir, why is it doubled? Because we took the square root. Diba? Because a square root can be a positive or a negative. We could have placed it in a positive there. Okay. So what's our final answer? The minimum integral value of k. It's in between 60 and negative 60, but is it inclusive or exclusive? I know, exclusive. So you don't include 60 and negative 60. It's not greater than or less than. It's greater than or less than, not greater than or equal to, and less than or equal to. So we're not gonna consider negative 60 there. Why did the sign change for this one? Wait, can we specify which sign? I have like 1, 2, 3, 4, 5, 6 signs there. Can you specify which sign is like changed? Anyways, so our final answer should be negative 59. Because we're not allowed to say negative 60 because it's no, it's not equal to. All right. So why did we change the sign? Because of this one. It's not equal to. Most of the time, regularly we see an equal to with our number. No, we see an equal to always. We see an equal to from greater than to less than. Ah, yeah. If it happens like this, if it happens like that, okay. If it goes the other way, you just flip the sign also. The thing is, the sign is gonna be always opposite that one. But if it's an equal to, continue with equal to, if ever. Okay. The reason why it's like that, because it's not equal to. Okay. Next up. How do you know if it's the opposite? It should be the opposite. It should be the opposite. But for equal, it doesn't really have an opposite though. So you can put equal. But if it's like this, place it like that. If it goes like that, you place it like that. All right. If it's like that, then you do like that. Just flip it over. Okay. Just flip it over. Next up. Find the greatest value. Ooh, maxima and minima. Now, what I'm gonna do is I'm gonna go with vertex form here. No, I'm gonna go with my vertex form. What the value that will turn this into a perfect square? Actually, this is actually a perfect square already, right? It's gonna be negative x squared minus 12x plus 36. So it's gonna be negative x plus 6 squared. So what's the what if you're familiar with the vertex form? I'm sure that's in your lessons already. Vertex form of a parabola is in the form a x minus h squared plus k, where k is the min or max. Okay, so what we're actually looking for is it x? Oh yeah, thanks for that one. X minus 6. Haha, nice. X minus 6. Okay. So what are we looking for this one? We're looking for this k here. You're looking for this k. But I don't see it though. I don't see it though. So what are we gonna answer? 0. File answer here 0. But if there's a number here on the outside, you should place that number in. But for this case, there isn't. No, luckily there isn't. So we're gonna place that with a 0. Okay. Next up. That's 6 equations and 6 unknowns. Find the value of r. Tricky one, tricky one. Let's try to evaluate this one. Let's try to evaluate this one. Now, although it looks pretty pretty hard looking because it's a 6 equation, 6 unknown. Third, do I need to form my matrix? Third, do I need to form do I need to break it down with a lot of equations? Because if you did this one manually, you'd have like maybe like 20 steps for this one because it's a lot. No, it's a lot. So we're gonna do I know it's doesn't here's the thing, it doesn't really actually apply for everything. There are a lot of systems of equations that this is applied to. This only applies because look at the pattern. 1 1 1 3 1 1 1 3 1 1 1 3 1 1 1 3 1 1 1 3 1 1 1 1. That's a good pattern for them. But again, that doesn't apply to all systems. Because solving a systems of equations nga five equations, five unknowns, diba? Two equations, two unknowns is hard. If you go with three, it's even harder. Get to five, it's gonna be really hard. Okay? So when you have this one, here's a shortcut for this one. We're gonna add everything. I'm just gonna add everything, right? So if I'm gonna add everything, the r's add up is gonna be 7r. The s's add up, it's gonna be 7s. The t is gonna add up, but it's gonna be 7t. The u is gonna add up, it's gonna be 7u. And the b's are gonna add up, it's gonna be 7b. And I'm gonna equate that to add everything 35. Okay. So what does that mean? I'm gonna divide everything by 7. That would mean r plus s plus t plus u plus v is equal to 5. All right, because I divided everything by 7. And note that 3r plus s plus t plus u plus v is also equal to 5, right? Look at this one. Got it there. Oh, sorry. So what does that mean with r? I can subtract both equations, and I would get 2r is equal to 0, or r there should be equal to 0 if ever. Ta-da! Okay. Next up. Okay. Find how many simplified solutions. Okay, how many simplified solutions are there for denominator 1001? So what we're gonna do is full order quotient. So how is it done? Get the prime factors first. 1001, that be it's divisible by 11, right? So like 7 times 11 times 13. All right. Now what are we gonna do? So we're gonna get our 1001. We're gonna multiply it with each distinct factor, right? So 6 over 7 times 10 over basically put a minus 1 on the top times 12 over 13. So when we get our final answer, it's gonna be 720. Final. Bit easy, no? Anyways, I know someone's gonna ask this one, so I'm gonna go in advance. Sir, what if it's like I know? What if it's like 7 squared? Do I put 6 over 7? Sir, no. You're just gonna need to put 1 for each distinct one. So even if you have 7 raised to 99 there, you're just gonna put 6 over 7. All right. So don't repeat. Don't repeat. if ever. Oh, yeah, you can look at this one. Euler's quotient. The name's weird, but yeah, you can look it up. That's the name. All right. Okay. Next up. Think finally. Ooh. We're gonna do something called Chinese remainder theorem. It's gonna be a bit hard, so hope you guys bear with me. No, hope you guys bear with me. Okay, so we're gonna do something called Chinese remainder theorem here. It has a lot of steps, so sorry in advance. Sorry in advance. Okay, so why does it include a lot of steps? Because it has three integral solutions. We can do it with 4 or 5 or 6, but it gets longer and longer and longer. But yeah, deal with this one. It's probably it's gonna take the longest. This is gonna be probably the longest problem for today. So brace yourself. Okay. So what I'm gonna do with Chinese remainder theorem is because it's three different modulos, right? It's three different modulos, and what I want with my modulo is I want to form them in such a way that they're like one single modulo. Okay. I want to have one single modulo. At the moment, I have like three. Okay. But I want to turn it into one single modulo, which is mod 455. I want to turn it into blank mod 455. Why is it 455 of all numbers here? It's the LCM of these three. All right. It's the LCM of those three. So what we're gonna do is we're gonna do something called Chinese remainder theorem to merge all three into this mod 455. It's a painstaking process, so bear with me for this one. All right, let's go. So how do we do Chinese remainder theorem? So we're gonna do a specific set of steps to merge a pair. Now, what we're gonna do is we're gonna do Chinese remainder theorem to merge this and that, and then we're gonna get a modulo. And then we're gonna merge it with this one. So we gotta do it twice to merge three. So if you have four, you're gonna have to do this step 3 times. If you have like 10, you're gonna have to do it 9 times. So for now, we have three, so we're gonna do that step 2 times. Okay. So let's do the first run. The first run will deal with that to merge these. Oh, sorry. I'll deal with that to merge these. Oh, sorry. Merge these two. Okay. So let's start with that one. So first off, I'm gonna change this one into an algebraic 5a plus 4. All right. So I'm gonna equate that one to the other one. 5a plus 4 is equals to 6 mod 7. Now I'm gonna transpose that on the other side. 5a is 2 mod 7. And I'm gonna replace 2 mod 7 with something that's divisible by 5. So 2 mod 7 is 9 mod 7, not divisible by 5. 16 mod 7, not divisible by 5. 23 mod 7, not divisible by 5. 30 mod 7. Okay. So 5a is 30 mod 7. Okay. So how do they get 30? You just keep adding 7 to this 2. No, you have a 2, right? And you just keep adding 7 because it's a mod 7. Keep adding 2 until you get a number divisible by 5. Why divisible by 5? Because it's 5a. And the reason why I'm doing that is so I can divide both sides by 5. A is 6 mod 7. 2 mod 7. Sorry. Yeah. It's a plus 4 and a 6. I transpose that on the other side. It becomes 6 minus 4, right? So 2. I just transpose the plus 4. Okay. So what am I gonna do now? I'm gonna this is equals to 7b plus 6. And I'm gonna plug that into my original equation. 7b plus 6 plus 4, 35 plus 35b plus 34. So when I merge that two, that's gonna be 34 mod 35. It's a bit it's a bit complicated, I know. It takes a bit of time to absorb. So you're gonna have your copy of your recorded video look into that one or look into that one. Okay. Now, we're gonna do it again. Now we merged this one and this one already, right? We merged them. And when you merge it, it becomes 34 mod 35. So what I'm gonna do is I'm gonna merge it now with 8 mod 13. That's why it gets a bit hard because you're gonna merge the more modulos you have. So hopefully in the finals, we're just gonna have 3. Because if you have 4, it becomes a bit tricky. No? So I'm just gonna copy this 35b plus 34, right? So I'm gonna change the pen because it's round 2. Round 2. 35b plus 34 is 8 mod 13. 8 mod 13. Okay. So I'm going to transpose it on the other side. 35b is equals to negative 26. Yeah, negative 26 mod 13. All right. Okay. So negative 26 mod 13. I'm just gonna keep adding 13 to this negative 26 till it becomes a number divisible by 35. Negative 26 plus 13, negative 13, not divisible by 35. Negative 13 minus 30, plus 13, 0. So this should be 0 mod 13 is 35, sorry, b. So divide both sides by 13 at b is 0 mod 13. So you can say b is 13c plus 0. You just like, you can write plus 0 if you want. It's optional. So we're gonna plug this back in here. So 35 B is 13C, right? 13C plus 0 plus 34. Our final answer is 455. Like what we expected, right? 455. That's gonna be our LCM. 455C plus 34. Or if you want another form, 34 mod 455. That's gonna be our final merge. Everything merged. It looks like this now. 34 mod 455. So what's the least possible integer solution? 34. Okay. So what are the other solutions? You just add 455. Keep adding 455. So 34. The next one should be 489 plus 455 again. 944 plus 455 again. 1399 and so on. The smallest here should be your 34. Bit brutal, no? Bit brutal. Bit brutal na road there. Okay. Next up. Whew. X is greater than 0. Wait, is this a joke? Ah, yeah, okay. Diba, less than 0 pala. Sorry, it's still greater than 0. Okay. X is congruent to 17 mod 29. So 17 mod 29, right? So it's X is less than 0. So what does it mean? Negative. What's the maximum negative odd number we can have? So, sir, how do we deal with this one? We said earlier that we can add 29 to 17, right? As many times as we want. So 17 can be 17 plus 29. We can replace it with 46. We can replace it with 75. We can replace it with 104. But you can actually subtract it from that. Okay? 17 minus 29, that should be, we can actually convert that into negative 12 mod 29. It's the largest negative, but it's not odd. So we're going to do it again. No? So negative 12 minus 29, negative 41 mod 29. Okay. So that should be our maximum negative na odd. Negative 41. Final answer. All right. Final answer there. Okay. So next up. Okay. Let's take 10. Time check. My time check here. Hong Kong Standard Time is, Hong Kong Standard Time, it's 2:28. We'll just meet back here at 2:38. That's, yeah, I know. Water and bathroom breaks. Basic. Okay. Okay, that should be it. Now let's carry on with our next step. No, we didn't have. Let's continue on with our second half. Let's go. X and Y are prime. Okay, and we satisfy this one. We can try an area way out of this bit, but I really don't recommend it. It's really a bit hard. So what we're gonna do is I'm gonna factor out this one. This is difference of two squares, right? So it's gonna be x plus 3y and then x minus 3y. Okay. And we're gonna factor 40. Okay. So we're gonna have x plus 3y, x minus 3y. That's gonna be, what are the factors of 40? We can go with 40 and 1. We can do x plus 3y, x minus 3y. That we could go 20 and 2. We could go x plus 3y, x minus 3y. Are we gonna try everything? Yep, more or less. And we're gonna have x plus 3y, x minus 3y is equals to 8 and 5. No, it's a lot, it's a lot, it's a lot. So what are we gonna do? We have two equations, two unknowns. I'm pretty sure you guys are familiar with how to deal with this one. Hopefully you are. I mean, I expect it to be like that, but if you're not, I know, too familiar with it, let's just another that one. Okay, so review your equation. So if this, so for the first one, we should have x is equals to, we're going to do cancellation method, right? So 2x is equals to 41, so x is 20.5. So nah, we're gonna crash this one out. Why? It's a positive prime. I can have a decimal for x and y. So if I had this one, this should be x is 11 and y should be 3. Good. If I had this one, I should have x is equals to 7 and y is equals to 1. If I have this one, I would get x is equals to 13 over 2, 6.5. I can have that. I can have. I'm looking for positive prime, so oops. Okay. So which one are we using? Are we using this one or this one? 11, 3, 7, 1. Note that 1 is not a prime. No, 1 is neither prime nor composite. It's a special number to begin with. No? So we're gonna do this one. X is 11, y is equals to 3. So x minus y is 11 minus 3. That will give us also 8. That'll give us 8. Next up. Whew. What we're gonna do is we are just gonna end that one there, right? We're gonna place it inside itself to terminate the equation. So it looks, this is, as you're gonna look at the next repeat of the pattern. It's this one, right? Next repeat. So I'm gonna put that one with an x. That's gonna be x is 4 square root of x. So we're just gonna solve for that one, no? So what is the value for this one? X. We can just divide both sides by square root of x if we want to, you know? So square root of x is equal to 4, so x is equal to 16. Da-da, da. Like so. This is an easy one. No? Hopefully it's not too hard on you guys. Okay. A four-digit number. All right. Wait a minute. Let's view, while we're at this one, I want us to view number one again. A four-digit number has exactly 3 positive factors. And if you look back into number one, you know, how do we get 3 positive factors again? The square of a prime. Square of prime. So let's recall that one. So if we want 3 factors, it should be a square of a prime going back. We want a four-digit number that's the square of a prime. Now, let's think of mga primes that we think it'll lead us to a four-digit number. Maybe 30. Let's try to 39 squared, right? 39 squared. That's 3 factors. 29 squared. That's gonna be 841. Nope. Let's go higher. Next prime is 31 squared. 31 squared. It's nice. I'm using a calculator if you guys are wondering why I'm like a bit solving it a bit fast. I'm not actually solving it in my head. Then let's go with next prime is 37 squared, right? 37 squared, that's gonna be 1369. So what's our I know what's it has to be a 4-digit number. The smallest one is 1369. Right? Squares of primes. Again, it has to be a square of a prime for it to have three positive factors. Okay? Square of a prime for three positive factors. Next up. Whew. 19. Mhm. Okay. Now, I hope you guys are familiar with dealing with x and y intercept, right? So what I'm gonna do is I'm gonna get the x and y intercepts of this one. X intercept, um, uh, y is that's gonna be negative 11, 0, and 0, negative 11, right? That's the x and y intercepts. I think I know are familiar with getting x and y intercepts. What are those? Those are the points where the points on the the points on the line where it meets the axis. So you just have to get x is equals 0 and equate, y is equals 0 and equate. Now, why did I choose the intercepts of all lines? Because it's passing through the x and y axis. That means it's gonna intercept. Okay. So I'm gonna try to draw my Cartesian, although not gonna look perfect. So you're gonna have to bear with me on this one. It's gonna be like this, like that. All right. So it passes through the x-axis and the y-axis, and it passes through these 2 points. The line negative 11 and 0, x is negative 11 and 0, maybe here. Y is 0, negative 11 here. Okay, so this is negative 11, 0. This is going to be 0, negative 11. And I'm going to connect my line like so. And it says it's bounded by the x-axis, so it's bounded by this. And also bounded by the y-axis, so it's bounded by that. Okay? So the thing here is because it's bounded by both axes, here, it's going to be a right triangle. So we can just use 1/2 base times height. What's the base? 11, because it has a length of 11, right? The height, 11 still. So 1/2 11 times 11. I'm not going to use negative because you don't have a side that's negative. That's going to be 121 over 2. Final answer. Hopefully not too hard. Or you could say, ano, yeah, 121. 60.5. You can say 60.5 if you want to. I can say 60.5. Either way is fine. Why is the answer key 101 and 2? There should be a mistake there. I'm really sure that's a mistake. No? 11 times 11 is 121. I think they switched the 2 with a 0. Right? Switch the 2 with a 0. Okay. So yeah, there might be a mistake in the answer key. But you guys do understand, right? Why we got the 121 instead of the 101. No? So hope that makes sense to you guys. Next up. Find the maximum value of sine 2x. Sir, how about sine? What are the what are the bounds of sine and cosine now? A sine, I'll give you a sine can be in between 0, negative 1 and 1. Cosine is in between 1 and negative 1 also. Tangent, so for tangent can be anything from infinity to negative infinity. You can have like any tangent for that matter. Okay. So sine 2x, what does that mean? Maximum is still gonna be 1. Because sine and cosine are always, no? If you can put 3x, you can use 5x, you can use 8x, you can use 20x, you can use 99x, or you can use like x over 5, x over 7, you can write that in. But as long as it's a sine, doesn't really matter what's in that parenthesis there. It's sine of what? It's gonna be 1 to negative 1. Same with cosine. Right? It doesn't really matter if you put 2x, 3x, 5x, 7x, 9x. It's still gonna be equal. It's still gonna be in the ranges of 1 to negative 1. So still the maximum is gonna be 1. Okay. Sir, how did we get that one? It's a property. These are the properties of sine, cosine, and tangent. Um how what how is this? I don't know, how did we grab this one? Well, it's gonna be in your trig class. Now, if you're done with your unit circle, you'll be able to get why it's like in between that one. Because it's actually the ratio, diba? Sine is actually, sine is actually the ratio of your opposite side, to the hypotenuse. And by definition, the hypotenuse is greater than the other side. Right? So a side over its hypotenuse, it's always going to be a decimal one. No? So at most you can put it 1 if it's a straight line. So the opposite side is going to be the same as the hypotenuse. But it's not going to go over 1 because the hypotenuse is going to be like the largest. So the opposite side can be at best equal to the hype, but not greater than. Right? That's that for that one. Number 21. Woo. Okay. 21. Now, here's the tricky part. Now, let's deal with this one, no? So, okay, we're gonna try to, they intersects at G. All right, they intersect at G. So what we're gonna do is we're gonna solve for the equation of these lines, right? We're gonna get the x and y values of these lines. So, just for the sake of like making it a bit quick, now I'm really sure you know the elimination and substitution methods. We did that with the earlier one. We'd get here x is equals to 6 and y is equals to 8, right? So what does that look like? What does that look like now? Again, not perfectly drawn. O is the origin. And G is 6, 8. X is 6, Y is 8, somewhere here. G, 6, 8. So what it means is I'm going to connect that one. And I'm going to get the slope. Right? Oh, the origin to G. So what's the origin to G? M is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. That's going to be M is 8 minus 0 and 6 minus 0. That's going to be 4/3. That's going to be our final answer. We got the slope of that one. Okay, just get the slope ends. Okay. Next up. Okay, triangle ABC. Ooh. Ooh. Okay. Okay. So we have a triangle. We have here a triangle. Okay, we have a triangle. And we have like, it's an isosceles. I know it's an isosceles. Why is it an isosceles? 10, 10, 12. So this is 10, this is 10, that's 12. Right? So we do know for now that's it. This is an isosceles. Okay, let's establish that. No? Let's establish that this is an isosceles. Yeah, isosceles. Okay. So here's the middle point. Now what we're gonna do is we are gonna find, okay, we are gonna find the I know here. We are gonna find the radius of this one. Okay. So how am I gonna deal with this first? Now, ideally, what I'm gonna do is gonna draw an imaginary line along the isosceles point. I'm gonna draw an extra line. Why am I drawing an extra line? Well, for good measure. You'll see. Okay. Now, okay. What I'm gonna do now, all right, what I'm gonna do now is I'm gonna solve for this imaginary line. Okay. I'm gonna solve for this imaginary line. That's gonna look like maybe half, right? This is your imaginary line. This is your 10. This just becomes 6 because that's half of the 12. So this line here is gonna be 8. This is 8 here. Okay. Now, what am I gonna do? How am I gonna solve this one? What I'm gonna do for now, I don't really like dealing with that 10 there. It's gonna be a bit difficult to deal with. What I'm gonna deal with is this one. What I'm gonna deal with is this one. Right. Should we deal with this one? Yeah, we should deal with this one. Okay. Anong maganda? Should we go with Okay. We're gonna extend it here. Okay, I'm gonna extend it here. Okay. Gonna extend it here. And what are we gonna form here? What's our goal? What's our goal? What's this side? No, what's this side? No. So this side is gonna be this side. No, no, wait a bit. That's gonna be no, we get that one. We get that one. That's gonna be our our and you can get that one. You can express that one. No? We can express that one as 2r minus 8, right? We can express that one as 2r minus 8 if we wanted to. Okay? If we wanted to. Okay. So what are we gonna form now? What's a good form siguro? Should we do anong maganda dito? Wait a bit. Should we do the top or should we do the bottom? We can do it in a trigonomic approach, but I don't think that you guys are like too into the trigonometry now. Not into the trigonometry as well. So how are we gonna do this? How are you gonna do this? Okay. Yeah. For the radius, inscribed circle, you could do that. Yeah, you can do that one. You can do that one, huh? You can do area, di ba? Yeah, area. You can do the area by Heron and ABC over 4A. You can do that one. No, so 10 times 10 times 12 over 4 times the area. Pwede ganun. Okay? Pwede ganun. Well, kinda, here's the thing. You can do that, but personally lang it's again, I'm stressing it. It's not for me, it takes quite a while because it's an isosceles kasi like we talked about it the last time now. I'm not really sure if you all are in the last week times, but last week we talked about the difference between when a triangle is right and when a triangle is not right. What's the difference between like a triangle that's right and a triangle that's not right? Well, the difference there is yung mangyayari doon is uh it's harder to find the area because if it's right, you can just go with 1/2 base times height. So for now, we're gonna use this one. All right. Now let's do this one. I'm gonna extend it here. I think it would be best if I extend it here. That's the radius, right? So this is the radius here. Okay. That's the radius. Radius. The radius squared is equals to how long is this one? That's half of 6 squared. How long is that one? That one is plus 8 minus r squared. Right? That's the 6 here. And this is 8 minus r. Okay. So what are we gonna deal with now? Now, why is it 8 minus r? Because this whole thing is 8. So this whole thing from the middle is your r. So this should be 8 minus r. Okay. So what do we have now? We're just gonna simplify this one. R squared is equals to 36 plus 64 minus 16r plus r squared. All right. I just like factor that. I just like squared it because there's a square there. And I can cancel the r squared. So what's left now? 16r is 36 plus 64 is 100. So r is gonna be 50 over 8, 25 over 4. That's your final answer. Yeah, pero pwede yun, pwede yun. Heron. You can heron your way there. Okay. Cosine BAC. Pwede, pwede. Pwede. All right. Now, let's find our sides now. Let's find our sides. Okay. Let's find our side. Find our side now. Now, what we have here is the issue at the moment is what are my values here? No? So let's draw I'm gonna draw my Cartesian again, not really perfectly drawn. 1, 0, x2, y1, and 0, 7. x0, y is 7. Looks like that. Very, very, very tricky there. Not very tricky there. Now, what are we trying to find? What are we trying to find? BAC. So our oh, wait a bit. Let's label I should have labeled it A and B and C. Now, if you look at this one, the middle letter is A, right? So that's gonna be where our reference angle is. Reference angle is A. Reference angle. It's the middle one, right? BAC. So it's gonna go like that. Check mark siya. Start here and end there. So our reference angle is this one. Okay. So cosine of this one. So how do we get cosine again? Ka, adjacent over hypotenuse. Right? That's ka. Okay. So how are we gonna let's get the sides. Let's get the sides. What we're gonna do is we are gonna try to get the sides of this one. Okay. So what are the sides of this one? Well, the small part here it's square root of 2 if you do this as formula, right? The other one, the CB is gonna be, wait a bit, CB. 2 squared plus 6 squared, square root of 40, right? And the third one is gonna be 49 square root of 50. All right, square root of 50. So if we're gonna deal with cosine, it's not dealing, no, not not an effective thing here if we did this one because it's not really properly built. There are other operations to do this one. So let's try another approach. Sorry. Try another approach. Let's do the cosine formula. Let's do the cosine formula. Cosine BAC is equals to AB squared plus AC squared minus BC squared. Now, what's the order here? Notice that A is in the middle, right? So the ones with A are the plus ones, and the ones without the A, the middle part, is the minus one over 2 AB AC. And again, the A, the middle one, those are in multiplication. So let's square that one. So it's gonna be 50. I know AB is 2, sorry. That's gonna be 2. AB is 2. 2 plus 50 minus 40 all over 2 times AB is 2. No, square root of 2, my bad. Square root of 2 times AC. AC is square root of 50. Square root of 2 plus square root of 3, that's square root of 100 or 10. The bottom is 20. Right? The bottom is 20. And the top is 52 minus 40, that's 12. 12 over 20 is 3 over 5. Final answer. All right. Nice. Next up. We have two angles and a side. So the most probable thing here is to do law of sines, right? I'm gonna draw my triangle ABC. Now again, it's not gonna be small angle, a large angle, and like that. Okay. So this is A, this is B, and this is C. B is gonna be 105. A is gonna be 30. So it should follow that this guy here is 45, right? Because the sum of interior angles of a triangle is, 45. So AB is 3 square root of 2. So we don't know these sides. We're looking for this one side, BC. Okay, so let's do the law of sines. 3 square root of 2 over the sine of what's opposite it, the opposite of that one. So opposite that one is 45 over 9, 45. And our missing side, let's call it x for now, equals to x, the side. And what's opposite x? 30. over sine 30. Okay. Here's the thing. We need to simplify this one. 3 square root of 2. Sine 45 is square root of 2 over 2, right? And sine x is 1/2. 1/2. Cancel out the 1, cancel out the 3. So x here should be equal to 3. That should be our final answer. Just a bit of cancellation. Why did you cancel? How did you cancel the 1/2 there? It's an over 2 on the other side, on the other denominator. And a square root of 2 they just cancel out. So no need to like transpose, multiply both sides. You could, but it would save a lot of time. Just cancel that one. Save a lot of time. Next up. It's given. Okay. Let's solve for this one. Now, this is a 3 equations, 2 equations to unknowns, right? So A and M. Let's go with A and M. A and M. So 5A plus 3M is 1950 G9, and 3A plus 4M is equals to 2050. So it's 3 equations to unknowns, depends on what you're comfortable with. For now, I'm gonna use radius question. Okay, I'll just finish number 25 and we'll get back to that one. So elimination 1. So what we're gonna do is multiply elimination method. You can do substitution if you guys want. Multiply by 4, multiply by 3. So this is gonna be 20A plus 12M is equals to 1950 times 4. 1950 times 4, 7,800. And we're gonna go with 9A plus 12M is 2050 times 3, 6,150. Subtract, because we're using elimination method, 11A is equals to 1,650. Okay, so if you divide 1,650 divided by 11, you're gonna get A is 150 grams. Answer. No, so just the 2 equations to unknown things. Anyways, here's a request to get back. Wait a bit. Can you specify which triangle? Radius. Triangle with radius. This one. No. This one. Yeah. We took the middle line and we got R. And R is from, this is, 8 minus R and 6. We will work with that one. Although, you could do, also, you have a good suggestion here. We dealt with it in our VTAMs, right? Like area, like ABC over 4A. You could do something like that. Okay, you could do also something like that. That would get your area as well. Okay. Pwede ganun. Next up. Okay. So 10 boys, and I'm gonna pick 3 boys. And 8 girls, I'm gonna pick 3 girls. So 10 boys, I'm gonna pick 3 times 8 girls, I'm gonna pick 3. So a bit easy on this one. As how we're getting the combination. Wait, I'm just gonna show you how to get that one. 10 times 9 times 8 over 1 times 2 times 3 times 8 times 7 times 6. We're gonna do it the long way around because just for the sake of it, because maybe you guys are not like too familiar with it pa. Like 3 and 4. That's 120 times 56. Our final answer would be 6, 7, 20. 6, 7, 20. 6, 7, 20. Final answer. Oh, sure. Oh, anyways, I think you guys have oh no, yeah, you can take a screenshot. I think you guys will have a recorded video of this one. It's better than taking a solution, right? I think. So you can view it there. Okay. So next up, a spare 6-faced die is thrown 3 times. Find the probability that the sum of numbers obtained is 4. a bit tricky. Now that's a bit tricky. Ah, exactly 4. So how can we build that one? So we can have 1, 1, 2, 1, like, sorry, 1, 1, 2, 1, 2, 1, and 2, 1, 1. That's the only thing, right? Obtain this 4. Don't think you can form any other set of dice that'll find a sum of 4 other than that. Those three. No? Unless it says multiples of 4 or whatnot, any other twist. But so far, I don't think there are any other, no? So, 3 possible ways. There's 3 ways to get a sum of 4. So that's 3 over 6 cubed. Why 6 cubed? Because 6 options for sa dice, diba? 1 to 6, and there's like 3 dice. So raise that to 3, or 6 times 6 times 6. So that's gonna be 1 over 72. Maybe. 6 times 6 times 2, yeah, 1 over 72. This one is a bit easy, no? One is a bit easy so far. Medyo doable sila. Okay. Woo! Woo, woo, woo. Okay. 45. Okay, so what we're gonna do here is we're gonna form our Venn diagram. All right, we're gonna form a Venn diagram. It's gonna be a bit tricky. It's gonna be a bit tricky. So I'm gonna form my 3 circles, and again, disclaimer: not really, not really like perfect at drawing this one. So you guys forgive me in advance. Circle here, another circle here, and then let's draw another circle here. It passes, right? It passes. I hope it does. Okay. Now there are 40 here. Oh, this is enough. This is Chinese. Chinese. 38 for English. And math is 37 and 37 for math. Okay. Now. Wait a bit. So let's look at this one. Let's look at this one. 36 students passed both Chinese and English. So 36. Okay, and then I'm taking it slow because I'm like it's a lot of numbers to process. English and math is 34. And 33 for this one. Oh. Okay. Okay. So it's a very tricky one, right? It's a very tricky one. Okay. It's a very tricky one. Because it's a 3-way Venn. No, it's a 3-way Venn diagram. It's a 3-way Venn diagram. So what am I gonna do with this one? What am I gonna do with this one? Wait. All 3. 32 pass all 3. All. Alright. So what 32. No, 32. So 32 passed all 3. So there are out this 33, like 1 is Chinese math only. Why? Because 32 passed all 3 and 33 passed Chinese and math. So there is one guy who passed like Chinese and math only. So there's 2 that passed English and math only. And there are like 4 guys who passed what's it called this? English and Chinese. Okay. So let's solve for how many pass all. Let's do that all. Okay. So 32 pass like all of them. 32 pass all 3. And 2 is English and math, 4 is English and science. So that should be 36, 38. So 2 plus 32 plus 36, that's gonna be at 38. So there are 0 that pass English only. Okay, 0 pass English only. For the next one, 32 plus 4 plus 1, 37. So there's 3 who passed Chinese only. And 32 plus 1 plus 2, 34, 35, 2 plus fast math only. So how many are there now? 32 plus each one for two subjects. 4 plus, so that's gonna be 32 plus the guys who pass all like two subjects. 4 plus 2 plus 1. And the guys who pass only one subject, 0 plus 3 plus 2. Let's add that one up. 32 plus 4 plus 2 plus 1 plus 3 plus 2. That's 44. So 44 of them are in this Venn diagram. In total, we're able to see that there are 44 of them in this Venn diagram. But there are 45 students, which means there is one student that's not inside this Venn diagram. So that student didn't pass any of the three subjects. So the answer here is one. One student out of the 45 because 44 passed at least one student failed all three. Really feels a bit bad. Anyways, poor student. Anyway, it's a hypothetical problem lang. And then so guess that gives us a bit of a bit of consolation. It feels sad. Next up. Okay. Two cards are chosen. Find the probability that the number chosen is 18. Okay. Now, our numbers are from. Here's the thing. Here's the thing. I'm a bit. I'm a bit. Anyways, let's just not consider it. I was thinking. The eighth box if it's like counted as one, but not needed anyway. So, anyways, so sum of 18. Now, we can go with 1 to 13 or you can go with 2 to 13, but if the ace is needed in some occasions, it's best to ask the Siguri or Proctor because they may consider ace as a 1. No, a lot of us consider ace as a 1, but yeah, ace is an 8, ace is an A. So maybe if you actually are there, best ask your Proctor if that one. Okay. Now, the sum of numbers of 10 is 18. How do you get that one? So we get 5 plus 13, 6 plus 12, 7 plus 11 until we get 13 plus 5. So how many are there? 5, 6, 7, 8, 9, 10, 11, 12, 13. 9 sets. Right? 9 sets. Okay, 9 sets. Why are they why are they 9 sets? 9 lang sila. Diba? How about a 4 and a 14, no? We're just at most a king is worth 13. You can't have like more than 13. That's all the sets for 18. Right? That's all the sets for 18. Okay. So what are our options here? What are our options here? So what we're gonna do is we're gonna do we're gonna oh wait. Forgot something. There is a specific detail that we missed. 9 and 9. 9 plus 9. Specific detail. I'm just gonna say 8 for this one. I'm gonna say 8 for this one. And I'm gonna place 9 plus 9 as a special one. Why is it a special one? You'll see in a bit. Okay. So for this 8, you have like 8 ways, and there are 4 times 4. Why is it 4 times 4? Because there are 4 suites, right? There are 4 suites. So like um 8 ways, 8 different like set pairs, and 4 suites for the first one, 4 suites for the second one. And I'm gonna go with 1 times 4 times 3. Why is there a 1 outside? It's because of this one. And why is it so special? Why didn't I do that one? Because 9 and 9, there is a chance that you get the same 2 cards. So it's not gonna be 4 times 4 because you got one of the same one of those cards is in the same group. So it's instead of 4 times 4, if it's the same, it should be in the 4 times 3 category. So I'm gonna break it down. So 4 times 4 and 4 times 3 and divide that by 52 times 15. Let's just deal with that one. So calculate 8 times 8 times 4 times 4 plus 4 times 3 over 52 times 51. We're gonna get 35 over 663. Bro. Okay. Do it lesser and better. More or less. Okay. Next up. Okay. Another typo. Wait a bit. I was like, it was a bit, it felt a bit weird. No? 10 and 10, 10 and 20. Sorry. That's I think your copy says 10 and 10 also. I just snipped this. Before we started, I just snipped this from the from the final mock. So if this final mock is when 10 and 10, yeah, it just means 20 because it won't make sense actually. But like how many 20 and there's 10 and 10. Typo. Typo siya. Hmm. Sir, are we really certain? I actually all the topics we discussed are generally we as far as VTAMS is concerned, we were told that the VTAMS is actually the closest. We expect it to be the closest one to the actual exam. So why are we talking about the mock exam? So the mock exam, it's for review purposes because they gave you a mock exam, right? So a lot of people do like to review the mock exam, but it's not really as we don't really expect it to be as accurate as the VTAM. VTAMs is gonna be the VTAMs lectures are gonna be a bit more accurate compared to this one. Um, when you say all, now when you say all, I mean 100% are gonna come out. We don't know that for sure. 100%. We do know what to expect. No, we do know what to, like when you're taking an exam, right? When you're taking on your MTAP and you're taking on your other contests, you do know what to expect, what kind of questions you expect. But you can't really pinpoint that out with 100% certainty. So it is close, but we can't really say for sure. That's what I'm gonna say. Okay. But as far as mock versus VTAMS, VTAMS is like really close to it. Mock is a bit far off. Also, I think the last revision of this one kasi is like 2015 pa. And now it's like 2023. So it's like 8 years delayed. This copy is like 8 years late on the latest math trend. So we didn't rely on this one. Best if you check your VTAMS. Yeah. Okay. Yeah, it's like that. Anyways, just correct your mock copies. It's 20. All right. 20. Now it's just but that's just the bank. Let's just go with A and B. So we go A plus B is 39, and we go with 10A plus 20B is equals to 520, diba? And we could just do elimination method and go with 10A plus 10B is 390. And we're just gonna subtract, diba? Elimination method siya. So like 10B is equals to 12, 1220. So B is 12. It's just actually uh it's actually just how would I describe this? A system of equations, two. A system of two equations. So that's that for that one. Next up. Yeah, I think that's that for our, let's do a quick run through. System of two equations, get the pairs. No, we got get the pairs of this one and get the probability. This one, we have to draw our Venn diagram, and I apologize, my drawing is not really that pretty, but try to review lang that one, right? Try to review on the It's a bit messy, and it's not required that drawing Venn diagrams is not really required, but it helps. Like it makes things 10 times easier if you have like your Venn diagram. But if you're good at it, if you're like you can like imagine your Venn diagram, or you memorized a specific formula for that one. But memorizing formula specifically is very case to case. I really don't recommend that one. Very case to case. I really recommend more on the Venn diagram. So whatever problems they're gonna throw at you, you'll be able to handle that one. This one, yeah, you just look at number of ways. This one, combination, like 10 choose 3 because we need 3 from the 10, 3 from the 8. Systems of equations again. Sine law, right? Sine law. This one is cosine formula. This one, you can do ABC over 4a. You can also do that one, no? Or you can do it this way. This one is just get the, again, system and get the slope with respect to the origin. This one is, again, sine and cosine and tangent property. 1, -1. This one, you just need to draw that one, get the intercept, and you'll be done. Factors, 3 positive factors, squares of prime. This one, you just need to place that in there to terminate the unterminating terms, no? The next pattern, the next repeating pattern, you plug in your x there. This one, yeah, we factored out 40, factored out this one, and we did trial and error on what our options are. Okay. Before the break, we did the modulo, no? Subtract, or add lang by 29. And this one, Chinese remainder theorem. Try to look into this one. It's a bit complicated. It takes quite a while. So yeah, try to view onto that one. Yeah. Sir. Does the sine question? Wait a bit. Sine question. Wait a bit. I have sine law here. Not really sure what sine you mean. There's sine law, and there's this sine. Which sine do you mean? If you could clarify that, that would be nice. No, there's like two sine questions. Uh, That is one. All right. Is this always? This is always hold. Yeah, that always holds. But if it's a combination of both, per se sine plus cosine, when it comes to this one, ganito na ha, or sine sine squared plus cosine. If it's a mix of both, this will not apply. But I individually, that applies. These properties apply individually. But if it's a mix of sines and cosines and tangents, it really doesn't apply. Because why? Sines and cosines are inverse. What do you mean by inversely? So for values of x from 0 to 90, if x increases, sine increases. But for cosine, as x increases, cosine decreases. So parang ganun sila. Like they are opposite to each other more or less for like small values of x. So they don't really match. They don't really match. So if you have a big sine, odds are your cosine is going to be small. If you're going to have like a large cosine, odds are your sine is going to be small. So when it comes to something like this, it's a bit complicated. How do I look into that one, sir? If ganito siya, if ganito, the best reference you have there is to review your unit circle. Unit circle. If it, unit circle. Okay? For this one, ganito siya, it's best that you try. It's gonna have a lot of like there's a term there. You're gonna have to dance through the terms, somehow change them into a single variable, or maybe dance through your terms, cancel what you can, convert what you can if ever, to make it like hopefully something doable, solvable. Okay. Going back, we were here. Okay. Euler's quotient, right? Distinct, I want you to write this distinct prime. So if there are two, example, 13 times 13, we're just gonna put only 113. Distinct primes lang siya. Next up, this one, usually systems, but we found a shortcut there because they had a cool pattern. Just add everything and like subtract one of them. Greatest value, vertex form. This one, di ba, discriminant and like the sign. Simplify, you just form, we expect the form to be like this, so we equate that, square it, you get your A and B there. And it's swappable, so don't worry. This one, di ba, we actually formed it like this. Okay? And we get our x plus y. But this is this is an HKIMO thing. In actuality, this doesn't hold. Anyways, you just think about it for a bit. This doesn't really hold, but it's in your HKIMO manuals. This is supposed to have no answer. No, like an infinite number of answers, but yeah, HKIMO is HKIMO. Okay, this one, remember your shortcuts on the sum of roots and the product of roots, negative b over a and c over a. And then you can get whatever they're gonna throw at you. This one, yeah, the date. No, 365 always. Don't forget your leap years. Okay, don't forget your leap years. Sir, what if January 1 and the other one is not January 1, but rather March 8, diba? Luckily, for this one, the year is the same. But what if it's March 8, 2023? You count the rest. You need to count the rest of the days. So familiarity with the days of the month, like which months have 30, 31. You need to familiarize that one because there's no easy way to count how many days are there from January 1 to March 8. You have to really count. Okay? So study on that one, if ever it comes. So we're gonna add the difference there. Okay. Light is on and off, odd or even lang. You just need to know if this is odd or even. You can look at the pattern of odd and even, or you can use the formula. This one, we remove. Oh, yeah, I actually double this one. This one, di ba? 31 4 is 5, and we do the pigeonhole na ano, pigeonhole formula. This one. Next up, this one, di ba? We expressed it in terms of its place values, no? Place values. Like this concept here. You know, the concept of place values. This one, yeah, it has a lot of like signs. A lot of I think in your we've been in the V times, right? And if you notice V times, there's only like two directions. Here it's like um 1, 2, 3, and 4. 4 times. And V times we only did 2. So I really recommend that you draw this one because it is gonna be if you have like a lot of a lot of I know he's gonna walk in different directions at different distances. It kind of becomes a bit hard to track. So I really recommend that you guys draw your arbitrary na map, kumbaga, right? And for one, yeah, friends, no? So we want 4 or more, so we just remove the 1, 2, and 3 factors, right? Yeah, question. Is there a VTAMP for final? I not exactly. Yeah. Technically, it's like VTAMPs, but the name is final round review. I think you guys a lot. I think you guys a lot of you guys are enrolled in the final round review, and yeah, we're still gonna have our no, we're still gonna have our 5 p.m. later. So for guys who are like with me in the final review class, we still have our 5 p.m. later if ever. So, but if you're not part of the final round, disregard that one. Anyways, that's that for that one. Um, any questions, clarifications, anything we need to know before we go? I guess not. 5, 4, 3, 2, 1. I guess that's that. All right. So I guess that's that for today. Thank you for being. I hope you learned a thing or two. So try to review on that one. If you have a hard time, try to look back on the solution video. This solution video. You can pause it. You can slow mo if you're having a hard time. Just try to, I don't know, study on that one. All right. Especially the hard parts and the parts that are a bit new to you. All right. So I guess that's that. Thank you for being with me today, and you guys. No, good luck for all you guys. Good luck. So I hope you guys uh do good on your exams, your finals, and yeah, go for gold. All right. See you and good luck.